Welcome to the Explainer. Today, we're diving into some really fascinating documentation covering one of the absolute most frustrating challenges developers face right now. Because let's face it, as we build increasingly complex machine learning models and generative AI workflows, our code is getting incredibly smart, but it's also becoming, well, entirely untraceable. We're building these massive, highly capable systems, but when something goes wrong, or even when something goes right and you just want to know why it worked, we're so often left staring at a completely opaque system.
I mean, it's a serious question. How exactly do you debug a black box? In the past, maybe you relied on manual logging, leaving that desperate trail of print here 1 and print here 2 statements all over your code. But in today's world of multi-agent LLM systems, manual logging is just a nightmare. It's incredibly noisy, it's so prone to human error, and it almost always misses the most vital context. Lost parameters, untracked hyperparameter defaults, hidden intermediate steps, they completely ruin your ability to optimize your applications. Because, at the end of the day, you can't improve what you can't actually see.
But going through the source material, the crucial point here is that you really don't need to rewrite your entire code base to get that visibility back. You don't need to wrap every single function in a custom tracking module. It turns out MLflow offers a solution that entirely eliminates the need for explicit log statements. It literally just takes one single line of code to crack that black box wide open.
So in today's Explainer, here is what we're covering. 1. The magic of autologging. 2. Tracking Gen AI and LangChain workflows. 3. Integrations with DSPy and Pydantic AI. 4. Controlling span log levels. And finally, 5. Visualizing traces in the UI.
Okay, let's dive into this. Section 1, the magic of autologging. Let's look at the fundamental mechanism right behind MLflow's automated tracking. The core promise here is pretty huge. You can log metrics, parameters, and models completely automatically. And the workflow? It's brilliantly simple. Step 1, you just grab MLflow from PyPy. Step 2, insert that magic one-liner, mlflow.autolog, right before your training code. Step 3, you literally just execute your code exactly as you normally would. And finally, Step 4, spin up the MLflow UI, usually just on your local host, and view your beautifully tracked results. That single line completely replaces the need for any manual explicit log statements. It's absolute simplicity.
So you might be wondering, what exactly is that one line capturing? Well, MLflow is actually smart enough to pre-select a set of metrics based on the specific model and library you're using. Whether that's Scikit-learn, Keras, or PyTorch, by default it captures your training and validation metrics. It grabs parameters, including the hyperparameters you specify, plus the default values the library uses, which, let's be real, are so often forgotten. It logs model signatures, describing your exact input and output schemas. It snags your artifacts, like model checkpoints. It even logs the dataset objects used for training. As a developer, you miss absolutely nothing.
Section 2, Tracking Gen AI and LangChain.
Now, traditional ML tracking is great, for sure. But when we look at chaining together Gen AI prompts, things get way more opaque. If you're building with LangChain, MLflow gives you mlflow.langchain.autolog. When you invoke your chain, MLflow automatically starts recording traces right behind the scenes. It does this seamlessly by tapping directly into LangChain's callbacks framework. So it recognizes actions like on-chain start and on-LLM start. It starts and stops execution spans to automatically record your inputs, your outputs, and the exact latencies without you needing to do a single thing. And it doesn't just stop at basic chains. This one command also supports LangGraph, so it automatically traces stateful multi-actor applications and agent workflows. Now, it's definitely worth noting that by default, this command specifically focuses on generating traces. However, it is highly configurable. So if you want to, you can easily toggle arguments in the autolog function to also capture specific model artifacts, detailed model signatures, and even exact input examples from your inference data.
Moving right along, Section 3, DSPy and Pydantic AI integrations.
Let's look at some more complex frameworks. If you've used DSPy, you know it is incredibly powerful for automatically tuning the parameters of a program, things like prompts and language model weights, to really maximize your metrics. But it is the ultimate black box. During optimization, the performance of individual trials is often completely lost. Intermediate artifacts, like the prompts and responses for intermediate programs, they just aren't saved in a structured way. You usually just get this massive wall of log texts, which makes it nearly impossible to understand the actual trajectory of your optimization.
Comparing these distinct frameworks side by side really reveals how MLflow illuminates them differently. With LangChain, as we just saw, it's all about traces and agent workflows. But look at DSPy. By using MLflow.DSPy.autologging, you suddenly capture the optimizer parameters, the overall progression metrics, and all those hidden intermediate program states and traces. And then there's Pydantic AI, a framework built entirely around strong typing and validation. Calling MLflow.PydanticAI.autolog tracks agent steps, tool calls, and model invocations, all while perfectly preserving their typed inputs and outputs.
And this brilliantly illustrates just how deep the Pydantic AI telemetry actually goes. It effortlessly captures agent calls with their full prompts and keyword arguments. It tracks LLM requests all the way down to the model name and parameters. It logs your tool runs and MCP, or Model Context Protocol server calls. And this is absolutely crucial for managing costs. If you're using MLflow version 3.2.0 or higher, it records your total token usage in the trace info, breaking it down per call right in the span attributes.
Next up, Section 4, Controlling Span Log Levels.
Okay, so with all this beautifully captured data comes, inevitably, some noise. Enter the span log level. This is a feature modeled directly on Python's standard logging module, and it classifies each trace span by its severity. So by adjusting a simple verbosity filter, you can hide all the internal chain plumbing, the parsers and the glue work, and focus strictly on the user-visible operations you actually care about.
The severity levels map super intuitively to the standard Python logging you probably already know. Debug is for your internal glue work. Info is for those user-visible operations, like your LLM and tool calls. Warning flags recoverable issues you definitely want to monitor in production. Error is for outright failures and exceptions. And critical, well, that represents hard stops that are probably worth paging your team over.
But what makes this so effective is the default behavior. It works perfectly, straight out of the box, without you needing to manually annotate a single thing. Spans for things like LLMs and tools default to info, while behind-the-scenes tasks like parsers and workflows default to debug. And here is the best part. If an unhandled exception occurs, MLflow automatically bumps that span's level up to error. This guarantees that failures remain highly visible, even if you've raised your verbosity filter to hide the everyday noise.
And finally, Section 5, Visualizing Traces in the UI.
All right, we filtered the noise, so where does all this data actually live? I want you to contrast these two realities. On one side, you have the absolute nightmare of raw, deeply nested JSON files that literally make your eyes cross as you try to manually piece together a sequence of events. But on the other side, you have the clean, structured MLflow trace table. Right out of the gate, it displays trace IDs, the inputs and outputs of your root spans, total tokens, overall execution time, and even links to prompt versions if you're utilizing the MLflow prompt registry.
Now, what's really interesting about this slide is what you see when you click into a single specific trace. You're presented with this highly visual span tree showing the exact execution flow. You can see latency timelines for every single step. You see the precise inputs and outputs of each span, complete tool definitions, and exception details if something happened to fail. And because modern Gen AI is multimodal, MLflow actually renders images, audio, and supported attachments completely inline directly within the trace viewer.
And for all the developers out there who basically live in their notebooks, as of MLflow version 2.20, you don't even have to tab out of your environment. You can view this rich, interactive trace UI directly within your Jupyter notebooks. Whenever your cell code generates a trace, or even when you just search for traces, the UI renders right there seamlessly, keeping you totally locked into your development flow. It is genuinely incredible how much friction is removed from the development process when you have proper observability. I mean, from standard Scikit-learn models all the way up to complex Pydantic AI multi-agent workflows, one single line of code truly does conquer the black box. It captures the metrics, traces the steps, filters the noise, and visually maps out the exact trajectory of your logic. So, with your codebase no longer hidden in the dark, the only question left is, what will you illuminate today?